When we come across handling too many variables in C, arrays let us store and manage data smartly. Good day and welcome to VSH Tech Studies. Let's unlock their power today. In this session, we'll cover the basics of array step by step. First, what an array is, then how to declare and initialize it. We'll also explore integer, float, and character arrays with simple examples and see how to print them in C. By the end, you'll have a clear foundation to start solving problems with arrays. Why use many variables when one array can do the job? Let's dive into arrays in C, the real game changer after loops. Okay? So if you visualize an array in memory, here we have array A. So it is a group of 3 consecutive memory locations here because its size is 3 here. All the 3 memory locations are identified by same name A, but the index of first memory location is 0, second one is 1, third one is 2. So if the size is 3, the values of index varies from 0 to 2. Once if size is declared in the program, it is fixed, it cannot be changed. So it is group of same kind of data elements means if array is declared of int kind, only integer type of data can be stored. If it is float kind, only floating point values can be stored. If it is declared to be of char type, then only character type of data can be stored. Okay, and they will be stored in consecutive memory locations, and it is a homogeneous data structure means the way of arrangement of data in memory is called as data structure. Homogeneous means same kind of data. So array has same kind of data, the data being arranged or stored in consecutive memory locations. So once declared, array size will be fixed. So these are some of the basic points regarding array. The understanding and visualization of arrangement of data in memory, the data structure, is very important. Only that understanding and visualization can help to write the code. Okay. Here we have a C program which is array based. So this is comment line, preprocessor directive, main function is here, its start, end, and return 0 statement which is the last statement in all C programs. So these lines are common for all C programs. Okay, and always the execution starts from main function. The first statement in main function here it is declaration statement. Int means integer data type. Here array of size 3 is declared. According to this in memory, array A, which is a group of 3 consecutive memory locations, is reserved. And in the statement here we have assignment also. According to this statement, the first location will have 11, second one 34, and the last one 56. This is called as array initialization. That is, assigning the values to memory at the time of declaration is called as initialization, and this is array initialization. Okay. The same can be achieved by doing declaration first and then doing assignment. According to this, 3 memory locations are reserved by name array A. Then as per this, 11, 34, 56 are saved in those 3 memory locations. Okay. Here reserving the memory space and assigning the values is done separately. The output of these two, that is in both the cases, nothing is printed on the monitor because there is no printf statement in the program. Okay. Now if you consider this C program, it has both array initialization and printing of array elements on the monitor. According to the first instruction, that is array initialization, in memory, array A, which is a group of 3 memory locations, that is reserved, and in the first memory location 11, second one 34, and in the third memory location 56 is stored. Next, according to second instruction, that is printf, on the monitor 11 space 34 space and 56 is printed. Okay. In this printf statement, within double quotes, the first percentage %d means that is integer value. Outside double quotes after comma, so the first variable, that is first memory location, its content is substituted and that will be printed on the monitor. So a of 0 means in that memory location 11 is there. So 11 will be substituted here and hence 11 is printed on the monitor. So after that space is mentioned, so space will be printed. So second percentage %d will be substituted by a of 1 here. So a of 1 is 34 and hence 34 will be printed. So after 34 here space is mentioned in the instruction, so space will be printed. Next, third percentage %d, there the value from a of 2 is substituted. So a of 2 memory location has 56 and hence 56 will be printed on the monitor. That is how this printf will print all the three elements of array A on the monitor. Okay. So in next C program we have three arrays, declaration and initialization. So in the first one, a array of size 3 is declared, which can store only integer type of data, and it is initialized with these three int values. So here in memory we have here a array, so where three locations are there which are identified as a of 0, a of 1 and a of 2. And as per this initialization, a of 0 will have 11, next 34, a of 2 will have 56. So according to second declaration and initialization, array B of size 3 is declared, which can store only floating point values, and these three memory locations, so it is a group of consecutive memory locations called by same name B. They only differ in index values. So each memory location is identified by same name B, but values of index varies from 0 to 2. So as per this initialization, B of 0 will have 8.90, then B of 1 5.3 and B of 2 7.956. Now third declaration and initialization will reserve three memory locations by name C. So size of this array is 3. Its name is C. So each is identified by different index. Here C of 0, C of 1, C of 2, which can store only character type of data. And as per this initialization, C of 0 will have R, C of 1 will have Y and C of 2 will have B character. Okay. So this program declares and initializes three different arrays. The first one which can store only integer type of data, second one only float type of data, and third one only character type of data. The names of arrays being A, B and C respectively. So that is shown with the diagram with respect to memory here. So this visualization of memory for any statement in the program we must be able to do. Okay, that is very important and the most needed one. Okay, since there is no printf statement, hence on the monitor nothing is printed, there is no output here. Only in memory, reserving memory space and assigning the values, that work is done in this C program. So in next C program, not only three arrays declaration and initialization, which is same as the previous program, that is done. Printing of three elements of all the three arrays, that is done. Okay. So this memory you can visualize array A, B, C and all the values assigned. That is done by this part of the program. So this output we have according to these three printf statements. So printing of 11 space 34 space 56. After 56 no space. That is done by this printf statement. So int value substituted by a of 0, that is from this memory location, then space, then percentage %d, that is substituted by a of 1. So that is this memory location content, that is 34. After that space, then this percentage d, there the value is substituted by a of 2, that is 56, then afterwards no space. So that is what is this output is printed because of first printf statement. So after printing 56, the control on the monitor will be in the next place. So next printf statement, it will print floating point value from b of 0, that is 8.90. So 8.90 is printed as 8.900000, means to the precision is 6 digits after decimal point. By default, any floating point value will be printed in C. So next b of 1. So here after that space is left. So b of 1 means 5.3. So again 6 digits after decimal point. So next space is left, space is left. Then b of 2, that is what is substituted here. B of 2 is 7.956. So 7.956. So another 3 zeros will be added there, so that to a precision of 6 digits after decimal point it is printed. So after that no space. Okay, no space. In the next immediate place only the control will be standing on the monitor. Next, according to the third printf statement, so percentage C means it's the format specifier for character. So from C of 0 memory location that is taken and it is printed here immediately after that 7.956 triple zeros. Then space has to be left, so space is left. Then C of 1, that is y is printed, space is left. So after printing y, space is left. Then C of 2, that is b will be printed. Okay, so b will be printed. So nothing. Next, no new line or no space. So next statement, return 0 means end of the program. That is how we have this being printed on the monitor as per these three printf statements. Okay. Now you can take a small question. Here all the three array elements are printed in the single line. Suppose if they are to be printed in separate line, first array A, then B and then C elements, what modification should be done in the program? So pause the video and try to get the answer. So the answer is after printing these three elements in array A. So before this double quote, we'll have to include new line character. Similarly here also new line character. So this will print array A, B and C elements in three different lines. Okay. So next C program has printing of array elements using for loop. These three declare three array variables and assign the values to all the three locations in each array as before. Here I variable is declared which can store integer type of value. It is going to be used as indexed in this for loop. So this for loop is used to print array A elements. So if you trace this for loop, I is initialized to 0, is I less than or equal to 2, that is true. Hence the control enters the loop body. There is only one statement that gets executed. So printf statement means it is printing on the monitor. So here percentage d means integer value, that is from a of y it is substituted. I at present it is 0. So a of 0 means in a of 0 memory location 11 is there. So that 11 will be printed on the monitor and space will be left here. Then after executing loop body, the control goes back again to for loop. So next, when control comes back to for loop, that is after one iteration, this time I will be incremented. I was 0, now it will be made 1. Is 1 less than or equal to 2? Yes, it is true. Hence control enters the loop body. The single statement which is there in the loop body gets executed. So it is printing statement. The control was left here next to 11 on the monitor. There percentage d means integer value from a of I. I is 1, a of 1 means this memory location content that is 34 is printed. So after this space 34 is printed, then because space is mentioned, space is left. Next control goes back to for loop. Next again when control comes back to for loop, that is after second iteration, I is incremented. It was 1, now it is made 2. Condition is checked. Is 2 less than or equal to 2? Yes, it is true because I is equal to 2. So again the control enters the loop body, that is printf statement. The control was left here, that is after this space the integer value from a of I, that is a of 2. So a of 2 memory location is here, its content is 56. So after space 56 will be printed, then space has to be left, so this space is left here. Hence on the monitor we have 11 space 34 space 56, and after 56 space is left. So instead of writing 3 times printf statement, the single for loop is used where index value is varied from 0, 1, 2 and the array referred is A. Each time the integer value is printed and space is left. This is executed when I is 0, 1, 2. Next time when I will have become, that is 3, for this it will not be printed because control will not enter, because 3 is not less than or equal to 2. It will have gone out of the loop body, that is return 0, end of program, and hence this output we have on the screen, that is 11 space 34 space 56 space being printed on the monitor. So this is how using single for loop and one I index and varying the value of index from 0 to 2 array A elements are printed on the monitor. So another two for loops, one for B and another for C array. If we include here, we can print the other two array elements also. So that is what we see in the next program. So in the next program we have printing of all the three array elements using three for loops, one for A, next for B, next for C. So this we have seen in previous program, it prints array elements with space. So 11 space 34 space after 56 space is there. So after that B array elements, so that is 8.90 means to a precision of 6 digits after decimal places. Then leave the space. So space, the next element again space, the next element again space till here from array B. So they are printed by this for loop. So after space here, so this for loop according to that it prints the array C elements, that is R, Y, B with space in between here. So this is how three arrays are declared and initialized. Then with the help of one index every time with three for loops here, the three array elements, that is A, B and C, are printed on the monitor. So understanding every line of this program, visualization of memory for every line of instruction, and how do we get this output on the screen according to these statements is very, very important. So that is exactly where it can help to solve any DSA problems. Okay. So a small challenge or small question for you here. So all the three array elements are printed in single line. What modification is to be done in this program so that they are printed in different lines? Put your answer in the comments so that I can know and check whether it is right. Okay. With that we come to the end of session. That's great job. Now you know not only what arrays are but also how to declare, initialize and print them. That's a big step forward in your C journey. Remember, every small concept you master is a strong brick in your foundation. Don't rush. Learning step by step is how real programmers are built. Keep coding, keep practicing, and whenever you have any queries, just drop them in the comments. VSH Tech Studies is always here to guide you. Don't forget to like, share and subscribe, because in the next session We'll unlock the true power of arrays with real C programs. Thanks for watching. See you in the next one.